Where does bad code come from? Part 2. I'm Chris Athanas. I'm a KMP developer. Tech support's coming out for that. Of course, you already knew that. And we're going to finish up the Molly Rocket, Casey. What's his name? What is his name here? Hold on. Let me forgot his name real quick. A brain fart there. Casey Moratori. So we're going to continue on in the context of adventure-driven development. Some more things about where does this bad code come from? Okay, let's just go. Here we go. And we're going to do that and there and go.
Talk and maybe they change your mind, or maybe you just accept what they say. Maybe you're critical of what they say. I don't know, but you get some input that way, and it affects what's going on in here. And again, when I look at this, I don't think we're.
I've only had a couple computer science teachers that really had an impact on me. And one was a digital electronics one, and one was that was at UTSA, and another one was a guy that was a substitute. It was not a substitute teacher. He was an industry guy, but he worked at he did part-time as a professor at a community college, and he taught assembly language, and that guy was great.
Doing a terrible job when it comes to algorithms or stuff like that. If someone goes online and tries to search for how to sort something, I don't necessarily think that they're going to find really bad information all the time. I don't think that's going to happen. You're probably going to be able to find the resources you need to learn how that sort of thing works.
Yeah.
So
it's been a solved problem since the 60s. So okay, 70s, all right.
What I'm really talking about is I'm talking about that other style of code, right? The part that's not the algorithm exactly itself. It's everything else. It's all of the infrastructure. It's all that other stuff that isn't really studied in the same kind of way, right? We don't have.
They don't know about it. It changes. Okay, first of all, it does change too much. I get it. So academia can't pick up on it. But also, they don't want to because it's too hard. Because they would have to be keeping up with the current trends, and because they have not been keeping up with this particular aspect of software development, with all these libraries and all these platforms and all these different IDEs and all this other. They've only concentrated on the thing that's been constant the whole time, which is algorithms, data structures, and algorithms, which has been constant the whole time. But this other thing's been ramped up, like TDD and the testing and the CI/CD and the deployment and all these different languages and versioning and how do you structure teams and how do you put all this stuff together. They have totally ignored all that stuff, and I know they've been studying it, but for some reason in the past 30 years, they just can't get a handle on it. They can't figure out what it is. They're trying to make it into an engineering thing, which they know how to do because they already went through that process, right? They already knew, we just copy like an engineering thing because you're at a keyboard. It must be technical. It's like, well, sort of. There's a level of that. Yeah, that's that sorting and data structures, algorithms. That's how things are laid out in memory, the hardware, and all that stuff. But then there's this other thing. It's like, how do we apply this to a problem that makes sense for the people that have to actually use this system, whatever we're doing with it? How does it make their lives better and easier, more cheerful, funner, less hectic, less time consuming? That part is sociological, psychological. It is context specific. It depends on where you are in the world, background, what your perspective, politics. I mean, it's a humanities thing now. Now, why haven't we studied how do we identify problems that we can then solve with the technology? Is there a field of study that even that is even called? Because that's basically all we do all day as software developers. Even there's no title for this thing, there's no label for it. That's what we're trying to do the whole damn time.
Order notation for it or anything like that. And pervasively, all throughout, everywhere in the industry, what you will see is things that are sort of vague statements about the quality of that code. It's clean, right? We're gonna.
Oh God, yes, here we go. Let's go in.
Really washing the code, it's very clean.
Washing the code, clean code. I mean, so one of the things I've noticed being in this industry since I was a little kid and seeing these trends come and go, there is this vein that comes through about acronyms because we have so much terminology like CPU and RAM and ROM and all that stuff. Instead of applying central processing unit, random access memory, read-only memory, was this thing that out loud we have these acronyms that then become the new thing, right? So the clean and solid and all this stuff, engineers love that stuff because it sounds like it's a defined thing, but it's not. It's idea sets that come into trends and come out of favor, into favor, are adopted for the wrong things and over applied, and we learn from doing that, and then it comes back, it's like, don't do that stuff at all. It's like, or it has some use cases, but never ever in a million years ever again. It goes through these trends, and this acronym thing is one of them. And engineers love to do it because it's like a way of signaling to each other that they're in the know or not. So clean and agile, even though agile is not an acronym, it's a keyword, that it's a signal to other people. Just by knowing the word, they think they know the whole thing. And like the whole thing about solid, and he'll get into it, but the whole thing about clean, it makes sense, right? For certain conditions and certain times and certain places, for certain projects, it's things to think about, yes, but are they the best practices, industry standards? Like, no, they never were, because the fact that they went out, if they're going out of favor or they're being questioned, or the people saying there's no statistics behind them, there's no proof. I mean, this stuff actually works, and we get to finally go through the calculations, find out a lot of this stuff doesn't do anything at all. In fact, it makes things worse. It creates a lot of bad feelings on people who are pushing these things, and then if it doesn't work out the way, so the people are like, you lied to us, and no, I didn't. I went to the conference, and they said it was the best, and that stuff.
Clean code. If you do these things, the code will be clean, right? This sort of thing. Ugh. And what we see is people are taught things that are ostensibly going to make their code.
Okay, I do want to say I have a response to this in my How to Program from the Ground Up. In my course, I go over the solid thing and how it's goofy and silly, and I have lots of videos that back up my stuff. And that the fact, okay, just to be clear the air. This acronym, SOLID, he didn't have an L, so he called his friend. He's like, I got S-O and I-N-D. I need an L. You need to put an L in there. So he found out the Liskov system, so he slammed that in there. And all this other stuff that he admits it freely. He admits it. You have to go listen to lots of video like I did. I took time out of my life to go discover where the hell this is, because this stuff is so vague and just like very airy-fairy. It looks great on stage. Sounds real great. Like it's really doing it. It's that people can make up stuff in their mind, what it means. I've never heard two different definitions of the same stuff with this actually how you apply this stuff. I mean, there's one that is a dependency inversion. Okay, maybe you pass your dependencies in, makes it easy to test. Yes, of course, it's easy, but should this be a movement, or is this quality software because you have a D? And then the people like actually applying all these things into their software, into their programs, but it's not necessary at this point in time. Like they're making a prototype, they're trying to put interfaces all over. Let's put an interface on everything. It's like, you don't need to put an interface on everything. Like you really don't. Some things will just be the thing. We're an abstract factory. We're gonna make it totally modular. It's like, nah. I mean, and these things. Okay, let me stop my rant. Okay.
Clean. Now they're never really taught what clean code is, because nobody has a definition for clean code.
Correct.
What they have is a series of things you're supposed to do in order to make the code clean, right? Like, in other words, we don't have a thing that's like a program you run that says, yes, clean code, no, not.
Right, but he's still going off. He's like assuming this is actually a real thing. This is what I call another conference-driven development, book-driven development. These people were authors. They're tech writers. They're in the biz. There are a lot of people that like to talk a lot. They like to have a lot of opinions about things. But can we see some of the things you've actually created with this? Oh no. That's completely proprietary. You never see our stuff. But I'll tell you how I did it. Blah 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 blah. It's like, could you show us some examples of how you put a big project together? No, none of that. Forget that. Proof? So there's a lot of this sales-driven, conference-driven, book-driven, author-driven, circuit-driven stuff that's been going on that's taken as gospel. So I just want to say that this is the source of this. Casey, so I don't know if you knew, if you weren't, I probably didn't go to these conferences, but a lot of people did. So there's this buzz that gets created from that everyone now has to deal with, because academia has fallen down on these types of things.
Right.
So they can't teach.
What we have is things you're supposed to do, and then the code is clean. That's all we know.
Wrong.
So you see acronyms like SOLID. This is taught a lot, right? And if you look at the things on there, none of them have any real-world definition. They're not things that happen inside a computer. They're things that happen entirely in your head. They are things that affect what code you think you are allowed to write. That filter is being trained to use these metrics, which are largely fictional. They're imaginary metrics we came up with. They don't correspond to a...
Okay, now I understand what he's talking about with the filter thing. Yeah, I mean, I guess that's one way of thinking through these things, but these are just ideas to keep around not as a filter. Like, we must go through these gates. If we go through these logic gates, then you'll have perfect clean code, and all your development issues will be solved. It's like, no, that's not where it's happening, man.
Hard measurable fact of a CPU, right? So we made them up. You're being trained not to write code that would violate these, or to write code that would like evince these, right?
Right.
Now, lest you think I'm...
That's the promise. That's the marketing brochure. Slick. If you read through the book, you do these things, you're going to be like, oh, you're like, okay, I guess. I mean, yeah, okay, one thing, each thing should have one thing. Yeah, you shouldn't be going in there and changing it all the time for every use case. Yes, you should, somehow, if you're doing that, you maybe want to abstract it somehow. Where's Liskoff? Why is she here? Why is she poking her? So she's talking about use interfaces? Is that what you're saying? Okay, okay. And then don't put too much junk in your interface? All right. And then pass your stuff in to make it tested. Okay, that kind of makes sense. Yeah, I mean, but this is going to cure your development issues. It's like, no, I mean, these are some things to keep in mind. A nice little reminder, like a meme that comes up that says, remember to brush your teeth and comb your hair. And, do you wash your clothes at least once a week?
I'm joking when I say that this is something that people are taught to do, because some people are like, what are you talking about? No one teaches that. Well, literally when I went to go grab the screenshot for Stack Overflow, when I was like, going to put in a slide for that, well, this was their blog, right? So literally the day I happened to grab the screenshot, their blog is telling people to do this.
I mean, I understand in the absence of everything. It's like, so if your head's on fire, you just find yourself with your head on fire. I was like, oh my God, my head's on fire. I need something to put it out. And somebody hands you a brick, and you use that brick to bash your head, put the flames out, as opposed to burning your hand, and you're not using a brick. You're gonna be real happy that grip goes on. And that's the situation we're in. People did not know how to create software at scale. They were completely baffled, super confused, really stuck. And some people figured it out. They went ahead. And then people are like, what did you do? How did you make that work? It's like, well, we did these things. And some of these little secrets came out. And some of these people have picked up on the most popular ones, slapped a book around it, went on book tour, got a conferences booked. And everyone's going like, oh, here's the new gospel. It's like, well, not really.
On Stack Overflow, the place where people go to get programming answers, right? So what these things all have in common, because solid's not the only one.
Now we go to Stack Overflow to see a bunch of people argue about what the right way to do something is, and upvote shit that was maybe worked 16 years ago or 7 years ago, and it has nothing to do with the thing I'm trying to do now, but it's all clouded, all people arguing and about what it is, and then arguing about the thing that they said that was the answer. It's like, come on, this is how we're going to do software development? It's like, no, that had to stop.
Plenty of other things like this where we teach clean code or try to convince people to write clean code.
I mean, okay, the clean thing, I do like the idea of having the stuff that's on the outside be the particular implementation of a database, particular implementation of some communications protocol. Yes, particular implementation of a local database, particular implementation of some SMS service. Yes. Then you have an interface that you talk to through that does the thing that you want. You talk to the interface. So instead of swapping out, you swap out the interface for it. Okay, yeah, I get that. That makes total sense. But like making it like you're predominant, oh my God, you have to do the thing. And that's only after you got product market fit. They never talk about this part. No, your prototype should be directly hooked up to the database, directly hooked up to whatever servers. You don't even have any customers yet. Why are you putting all that extra stuff? You don't even know if you're going to use this thing. No, directly hook it up. Now, after you put your MVP, maybe you put an interface there for some things. Other stuff, just leave it alone. The stuff that you may know you're going to swap out in the future. Not your room database. Let that just be the thing. Just use that thing. It's like, I've seen these programs, interfaces for everything. It's like, dude, you don't need all that stuff. Now, if you go to production, yeah, maybe you could think about what things are going to be need to be battle hardened, whatever. But usually by that time, we're not making those decisions anymore. It's like, should we go write the new one? Stop trying everything, disaggregate everything. And some things just don't need to be tested so much. Like, come on. Like, reduce the amounts of things that tested, and do test the interface. Don't test the damn implementation. Holy crap.
What they all share is one very important, very bad characteristic, and that is they do not attempt to measure anything.
Correct.
There is no measurement.
Well, we've had the measurement. So in the 3 years that this video came out, we've had some measurement. Yeah, it turns out Agile's stupid, and all these things that have been applied all super strictly don't make a difference. In fact, they cause lots of problems. Mostly hurt feelings. Mostly hurt feelings because people are bashed over the head by these things because the people at the conference are so, oh, I know what's going on. I'm your uncle, and I would never lie to you for money.
Of anything that we would actually care about. It's simply implied that things we actually care about would happen if you follow these things, right? If you take your code and you make sure that it obeys the Liskov substitution principle for all like classes that could be substituted or something, nobody has any argument anywhere that I've ever seen that suggests that that actually improves some real-world metric that we've measured.
Right, because that's not where it came from, sir. It came from a man needing the letter L in his acronym to make it sound like solid instead of soyed or sigid or sogad, a sigid, a dogad, a soyer, a doyas, a des, a diggy. That is the whole reason. And the fact that it says solid makes you think like, oh, this is gonna make my code so it doesn't stop crashing in production every 5 seconds because I haven't figured out a not couple things like failure points, so I can't even test the thing. I don't even know how to think. I can't test this thing. Well, you gotta put an interface. I'm like, interface to make it testable? What are you talking about? It's like, yes, it's dependency inversion. It's like, so that was like a light bulb moment for a lot of people, right? And they figured the rest of it would be light bulb moments. It's like, no, not really.
The assumption is that if you do that, your development process will take less time, or be smoother, or have less.
Oh. All right, my machine burped here. Let's keep continuing.
Some real-world metric that we've measured. The assumption is that if you do that, your development process will take less time, or be smoother, or have less bugs or something.
Right.
The code will be cleaner. It's just an abstract statement that if you do these things, the code will be cleaner, and somehow that will affect something you can actually measure. Yeah. But we're never going to say what that something actually is or try to quantify it.
Correct.
Now,
because that would mean that they have something on the line. So because they never did that, it's totally okay to go in on those fools because they actually promoted things and people really took it for granted. And they were they're very sincere. But this tech simp thing has to end. You have to see that some of this stuff is done by people who really should not be listened to. Maybe they're trying to sell you something, like all these vendors with all these lock-ins, with all these services and cloudless. We can get rid of your on-prem. Yeah, but you get a huge bill that you can't control. Oh, look at that.
I mean, seriously, look at these things, right? Is any of those teaching somebody to actually think about a real effect?
No.
No. They're teaching people.
Maybe single responsibility depends. Maybe, but those are kind of like, okay, side issues, yes. If you want to do testing, it's like, because testing's not taught in academia, it's like a thing that happened out in the wild, and they haven't even done it in 20 years. They haven't gone up like, hey, add some tests to your thing, makes it easier to understand for yourself and other people. No? Okay.
Something they're supposed to do, which is taking that filter and modifying it. But it's not actually giving it any actual guidance about like a metric or something they're trying to accomplish.
Right. So I'll say it again. A lot of this stuff is trade secrets, man.
It's just rote.
Money.
Now, to me, that's just like a ritual, right? If you're literally just saying like, you do these sets of things and the code is.
Yeah, so it turns into a cargo cult. So there's been a lot of that stuff happening. That's because a lot of the people that go to the conferences are these preserver types who are working. They've got these jobs. They got some bosses. They got a budget. And they need to get their production thing out of the way. And they don't like dealing with these creator destroyer types. They just want to know the checklist that they can give the people that they can do to get through the leak code, right? To then just do the thing that makes the software work. And they're just like, if I do the checklist of solid, and I have all the checklists all down the list, and I contact him and he go through his week-long conference course, and we buy all his extra upgrades and bring him on as a consultant.
Is clean. It's very much like, oh, like we're going to bless the food before we eat it, right? And these might make you feel better, and you may want to do them.
But because have you noticed how confident they are? How the uncle, he's so confident. Some stuff is correct. It's like, yeah, it actually works. But really, this is the guy.
But at the end of the
show me some of the software he's done. Let's critique some of his code. Let's critique his applications. Looks like what his customers say about his customers are you guys. Oh, the developers are the customers. You have no way to even combat. You tech simps don't even have a way of combating what they're saying. How about some numbers? How about some proof? Does this actually improve anything? Instead of just like, yes, this is the way to go because I went to a conference. And there was a guy on stage. He was very confident. He had a book. It's like,
the day,
stop, guys,
they are not directly
goddamn.
tethered to anything we actually care about. Rituals may have served a purpose once, or they may never have served a purpose. And when we do them today, what we're largely doing is just doing them because someone told us to do them. They claimed that by doing them, we would get some outcome. But we're never really told.
They just said it. And nobody was like, hey, we should follow up. It's like, you're not doing it right. You're not doing L correctly. That's your failure point. You think L, not my crazy mixed up, but I need to get rent paid. I need to buy another house in the Hamptons. Like, I got to get fuel for my private jet.
How those rituals were supposed to really accomplish that. We're just supposed to assume that they do. Now, this is
I never just came up with scam-driven development.
troublesome because computers are actual things. The model in your mind of what I'm targeting when I'm trying to make my code and I'm trying to do that filter, that process, the generator filter process in my brain, if what I'm targeting is solid, I'm by definition not targeting the actual computer.
Correct.
Right? The thing that I'm supposed to be worrying about, which is a computer that runs this code, is nowhere to be found in that acronym.
Or the customer, or meeting the requirements, or how to structure things so multiple people can look at stuff. How do we make APIs? How do we decide where the barriers are between things? How do you decide what a boundary is? How do you set things up so we can scale it and extend it and make it easy to modify and understand? Not a huge clusterfuck of a bunch of Docker images and things spun up and all these different things. We have to use a Kafka and all that stuff. Is that really all that stuff is really necessary? Is there a way we could build this into the code somehow, or into the operating system, or into just how this stuff works? Instead of adding all this crap on top, that have to be configured and aligned and checked and debugged and updated. And version 1.6.7.72 is not the beta version you need for this particular server and this instance with this load, with this combination of Postgres 1.6844, etc., etc., etc.
Right? It's not there anywhere. Furthermore, I'm not measuring my development time. Solid, nowhere in it says, hey, by the way, actually these are all just supposed to save development time, so if you end up seeing that you're not saving development time, stop doing it, right? Nobody says that.
Never. It's implied. It's the burning hair brick. It's the burning. Remember when I talk about the burning your hair's on fire? You want to
right? So I don't want to give you a new acronym because I don't think it's very useful. But to underscore the difference between that acronym...
I have a good acronym. So in my course, How to Program from the Ground Up, and also the Adventure-Driven Development, I have the thing. The one of this I like. This is a Cupid. It's down here. It's how to think about structuring stuff right here. Here, composable, Unix philosophy, predictable, idiomatic, domain-based. It's still just some conceptual ideas. There's no dictates that will just you will make your code faster. Just think to think about. That's all it is. And then here's the talk right here you can listen to about Cupid, which I really actually, if there's any of the acronym shit I like, Cupid's I like that one. It was pretty good.
Acronym and what I would have expected to see the trite acronym be, I would expect it to be something like this. I even arranged it in a way you can say warmed, just like solid. And what this is just say, look, if we're going to teach something that goes up in the filter, what it should be is the actual things that programmers need to care about.
Yeah.
And then if something like solid was
down to the metal. So I've got more how do we combine, how do we like work this stuff together with the Cupid? How do we talk about things and how do we make things easy to understand and modify and extend and pass off to somebody else, easy to document, easy to see what's going on. So there's not a big mystery. How they get this, it doesn't take hours to get the thing launched. Yeah, this is down at the bottom. Like when you're as a programmer, like right, okay, let's do it.
Actually a good idea. You would be able to evaluate that very effectively by caring about things we actually do. And to me, those things are writing the code, agreeing on code if we have to have more than one person, reading code, because not only did we not write all the code usually, but even if we did, we might forget what we wrote. So if you're able to read it, we have to be able to modify the code has to execute on hardware, and then we have to be able to debug it, right?
Yeah. Yeah. So we usually do the write and then execute. And we're like, debug. It's hard to debug. Yeah, but they agree and then writing it for someone else to read it. This is something that takes a long time. This is that creative part, right? To write something so not just you understand it, but someone else is like, oh, that's scary. If someone understands what I do, won't they just steal my job? This is very common as well. I have the secrets. I make it complicated on purpose, so only I will have the ability. You can't get rid of me, right? So if you write code that's understandable for other people, oh, you're letting it go now. Ooh. So this is a big thing in our business as well. Talk about money, where this is money, this is jobs, this is people's livelihoods. This is serious business. Hey, I want to go to a boot camp and I want to be paid the same as someone who just went through a computer science course. And if it takes me holding on to this thing tightly and I'm coming up with amazing stuff, and people can't figure out how to do it, and it makes me an integral part of this organization, this team. You don't think I'm not going to do that? So you don't think some people are going to do that?
Now, if you look at these things, maybe you would say argue is better because like coders don't agree on stuff. They argue about stuff, right?
Yeah.
But either way, whichever one you want to think of it, it's still the same acronym. So, I made sure that would work. Now, each of these things...
If you're arguing for the right reasons, to make it more understandable, to make it more extendable, to make it more readable, to make it more modifiable, those things are good to argue about. If it's commas versus like spaces versus tabs or all those bullshit, it's like stop.
Is a cost, right? That's what I'm talking about. Each of those things is a cost. Execution is a cost of the actual computation. It's the most important cost, the E, right? How much does it cost to execute this thing on the end user's computer? They're the people who are ostensibly paying us, and we are wasting their time if that cost is very high because we ship them something lousy, right? The rest of the costs are development.
Some of that stuff seems to be, it is an intentional waste of time. Have you seen some of the Google ads? Some of the stuff people have discovered where you're paying for some click farm in Indonesia that does a VPN into your local area and just clicks all over on pages in your area and charges you for it. Oh, it's bad. So yeah, so maybe that is part of the business plan, part of the
time, right? And those affect the customer because if we never get the code done, or if it takes us too long to fix problems in the code, or if it takes us too long to add features, that affects the customer too. So all of those things are costs that we ostensibly care about. And while I would say maybe execution should be prioritized, they're all important, right? You can't just focus on one at the exclusion of the others. So what you're trying to do is figure out a way to minimize all those costs. And you kind of want to minimize as many of them as you can with maybe different weights on them depending on what you care about most, but that's what you're doing. So again, pretty simple, right? I've never seen anything like this. You don't go to conferences and have people say, like, look, this is what we should be caring about. Let's try to evaluate things on these. And people maybe throw up their hands and say, well, you can't possibly measure these things. Yes, you can. I mean, it's very easy to measure how many GitHub back and forths people have before they actually fix an issue. It's easy to measure how many.
Yeah, so we've discovered that a lot of the things that we thought were these best practices ain't. And really what it has to do with is like, so we have these managers who go to these conferences, right? And they're given the new holy sauce to drink, the new medicine that'll solve all the problems. Instead of looking at like, okay, what are we really doing here? Do we need all these things? Can we take this stuff out? Can we delete stuff? That's just not a conversation. That's what goes on. Can we start over? Can we write it over? That's also not a conversation that goes on. Maybe this stuff is crap for a reason. Maybe it was written in a hurry. We're going to sprint. We got to do every sprint. We got to go as fast as possible. Break things, make things, blah, blah, blah. And those people are gone. They quit 2 years ago. And we're still trying to maintain their stuff. Stop.
Meetings you're having. It's easy to measure how long it took you to write this piece of code, right? We are an industry that does an infinite amount of A/B testing on our users, and yet somehow we don't seem to think it's very important to actually do like A/B testing with any kind of metrics.
These A/B tests, these stupid ideas. No, it's always shame the guy that brings it up. Shame the guy that brings up maybe this isn't the best. You go, those other conferences cost me $2,000 a head. You can't tell me.
Any of the stuff we claim we're supposed to be doing, right? So let's try to bring it back to bad code. Where does it come from? Well, I tried to give you the analogy. Programmers are explorers. They're starting from somewhere, and they have a vague destination in mind that they've been told to get to or that they picked, and they have to get there. But they don't have any real knowledge of where it is. Yeah. Well, in this analogy, what we've done with all the stuff I just said is effectively, instead of giving them something like a compass, we just give them tools that don't make any sense. We give them like a hammer and a tape measure or something like that, right? Yeah. And we're like, here you go, set off on this journey. Here's a hammer. Now, the worst part about it is it's not even as bad as giving someone a hammer, because the real world person would know that the hammer is useless and throw it away. We've told them that this hammer is critical for navigation. So they're like trying to like hold it up to the sun or something and figure out like which direction they're going. They have no idea that we've given them tools that are not even relevant to the problem that they're solving.
Yeah. The average, like the computer science graduate, the average boot camp, they don't know anything about how to like actually structure problems, how to like deal with customer issues, like how to actually build this stuff. It's just, here's how you do the list on the screen. Here's how you do an API call. Here's an HTTP request. Like, dude, that's this. You got to know that stuff. Agree, you got to know it. But this is all this layer they're completely ignoring, like it's not there. It's like, oh, never heard of it, never seen it, don't know why. That's your problem. You're not doing it right.
They're not actually tools that measure anything. They're just arbitrary. We just gave them to them and said, here you go, right? Similarly, we spent all our time talking about a map that doesn't exist. We're talking about things like Liskov substitution principle as if that has something to do with programming. Now, it has something to do with certain ideas in certain languages that someone hypothetically thought might be important, but it's entirely fictional. It's like Middle Earth, right? Lord of the Rings might be a great story, but if you actually need to get from South America to Africa, it's not going to help you to be thinking about like where Mordor is on a map, right? You have a mental model that's been tuned for things that have nothing to do with the actual stuff you're trying to solve. So we shouldn't be surprised when like new programmers come up and they just do ridiculous stuff and these things blow out of control because they had no metrics. They had nothing to tether them back to what they were actually trying to accomplish. We basically made their entire filter process be about things that are different from the actual things we want to achieve. What else would we expect? Right? So I think in modern day, when you've gone up through that system and you didn't have the luxury or the hardship, depending on how you want to look at it, of having to do programming in a constrained environment, you end up thinking that things are completely insurmountable. You're like, I don't know how we would ever do this program any differently than what we're doing, right? It's got to be a million lines of code and super slow and buggy and like this is just how it's done. You can't.
This is how it's done. We have been given from the programmers that came before, the destroyers and the creators. We were given this code base. Now, so it was an MVP that got promoted to production, yes, but now you are now assigned to fix all the bugs and errors and side conditions that they put it, that they didn't know were there, but they are part of this process now, and you can't talk to them, and they're gone, long gone, but you're now expected to deal with all that. No, we're not going to write it over. Are you insane? We have $6 million in that code base.
Even envision what the other thing is because you haven't ever been given the tools to get there, right? And furthermore, you're going to be having taught a lot that code reuse is good. Well, the problem is the code that you're going to be reusing, right?
That was the promise. That was the promise. Like, we can reuse our $6 million investment. You mean we can just use it over again? We don't have to spend over again on that? Like, no, that's not what we meant by that. That's not what you bought in onto it. That's not what we meant. It was like the class hierarchy. There's like stuff in the root that's common to all the hierarchy. That was the code reuse, but not the. But then they somewhere along the way they changed it to this. You mean I can reuse the code I already spent money on?
I mean, that's like in the analogy of navigation. That's like base camp, right? It's like starting out at a camp that someone else made. Well, the problem is they were lost too. They have no idea where they are. So you're typically taking a library made by somebody who didn't really know what they were doing, and that's your new starting point, right? Yeah. So people who failed to get to a destination that we wanted to go to are now also the jumping off point. And this gets worse than libraries. Whole languages, whole platform ecosystems are this way. So
Java that is a great example. C++. Now Kotlin's a refreshing start, but eventually I'm sure it'll be all subsumed at some point in the future. But the how it's been going so far, the 10 years has been like, no, we're just do this, we do this. Very minimal changes, very minimal things that really are idiomatically aligned with it, and it's coming from one company, one set of people, one vision. But I'm sure eventually it'll get off in the weeds.
So we're literally
for now, it's working pretty good.
Starting our navigators off, already lost in the wilderness with no chance of ever getting to the actual place, making it way harder than it would have been if we just started back in port originally.
Yeah, for sure. So it's like, Java really jumped the shark with all the feature stuff and all the stuff that happened, right? So it's like the Kotlin started off at a different base level, right? So the Java was like way up here at this thing. It's like, we're not going to start. Like, they started off at a different level and retraced some steps and took some better decisions, right? In light of the Java experience.
Right.
Without Java, we wouldn't have had Kotlin. Just, come on.
But they don't know that because we've never been measuring any of this. So can this be fixed? I mean, sure. I think it can obviously be fixed because we have examples in the past of programmers being trained up not to do these things. Right?
Well,
and so I think
we're not expecting industry to fix it. Like, people like me and you have gone down this, if you listen to this video this far, we're the kind of people that will fix it just by doing it differently. We're not expecting the whole industry to change. Come on now. This is the kinds of thing you're asking for take decades. Because it took decades to get here. And it's different. It's like basically saying, look, man, the way you teach computer science, you have to change all that. You have to change all of it. And how are you going to do that with academia being how it is? Like, no, this is an engineering practice. We've already figured it out. It's like, okay, guys.
The first thing we need to do is like start talking about the real world. Whenever we're talking about something, conferences, programming language constructs, all these things, we should be talking about how it actually affects the results. Construct a real argument.
Well, you have to get people to stop being simps and stop falling for everything you see at these conferences that are taught by an obvious huckster who really knows how to he knows how to speak very well. Let's just say he's been on the circuit a hot minute, man. These guys are on the circuits for a hot minute. So let's like have a jaundiced eye to some of these people. So I'm like, oh my gosh, you know everything. Oh, we're gonna listen to you. And it's like, stop, guys.
For how a number goes down in the cost category, right? We should be giving people tools, like the one I suggested, that actually measure something we care about, not something we just assume that we care about, because that will lock it in, right?
Well, the other thing, Casey, is like a lot of this stuff isn't measurable, right? Risk isn't measurable. How long these things are take is a total pipe dream. A lot of this knowledge work is wasteful on purpose because you're trying to find a route that nobody's seen yet. You're trying to go areas that people aren't there yet, and maybe never will be. So the very nature of it is lacks measurability for the because it's knowledge work. Once the widget gets defined, we can measure all that shit. But how long it takes to get the widget made? Eons. How long did it take Woz to learn how to add color to the Apple II without having $5,000 chipset? It took him a year because he was delirious from writing that breakup game. He looked over to the color screen to the screen with the little plastic tint color, like the light tints on there, so the different rainbow colors. He saw that little ball pass through the thing, and that gave him the idea that, oh, when the electron beam is going across, I can wiggle that thing and make it do something off to the side that makes color happen. So how long did that take? How many sprint tickets was it that? That's knowledge work. It's inspirational. And if you're at the right place, at the right time, with the right people, in the right atmosphere, it's very luck based. Sorry, I had to break it to you. I saw a good idea of that. The color thing was a great idea at the time he did it, but it was dumb. 10 years later, it was like doing something else. We're doing a completely different way. We're not even Apple One. We're can't do the bus timing based on the color signal for TVs. We have to get past that. That's what a Macintosh said. Anyway, let's keep going.
All of these things are very much like the sort of navigation base camp analogy. Anytime we start someone off from a place that we haven't verified is actually really good, we create a huge problem for all the things they will do in the future, right?
I mean, sort of. Sometimes having a bad thing is how you create the good thing. I mean, maybe you don't start off with that base camp. You have to go do another camp someplace. Scotland did. They started someplace else.
And when I talk about things like that, what I'm saying is don't just say stuff, right? Don't just talk about this is clean code.
Well, sir, we talk about stuff all the time. Now, I think in the future we should be less simpy and like have people prove some of their stuff before they just blurt it out and everybody just goes, "Oh my God, you said it so confidently. You spoke so confidently." And the manager goes he goes back from the conference and is like, "This guy's got it. This guy's really nailed it, guys. We just need to do a solid thing. Let's go."
Actually measure. Have something we can measure. This produced less lines of code for the same equivalent execution, right? Not it's less lines of code, because if it's less lines of code but it runs worse, that didn't help anybody. This is less lines of code. It's easier for people to read.
Well,
why?
Maybe. I mean, these things are hard to measure, but they're definitely measurable. I mean, you could take this stuff should be the next guy that comes up with something should say, "Hey, this is how we would measure it." And like the adventure-driven development stuff, I don't even know how you would measure any like that. Some of that stuff, it's so random that when something hits, but if it does hit, it's always been adventure-driven. That's the thing. It's like you have all these failures, but the ones that do hit were based on what I'm talking about in adventure-driven in this series.
Not because we talked about it and decided it was easier to read, but because we actually checked. When a new person comes to the company, they are now able to read the code faster.
But that's that person. So we test 1,000 people. Some of these things are not practically measurable. But I get the sentiment. Yeah, okay, I get it.
It used to take a day for them to read this part and come up to speed on it. Now it takes 2 hours, right?
Yeah, maybe he's a genius. What's his IQ? Are we going to test his IQ before he gets something? I mean, these are people, right? So they're very variable, especially in this business. It's all over the place.
You can measure this stuff. It's real world stuff, right? And of course, start actually measuring the performance of things. People actually knowing what the performance of something should be. That should have been fundamental the whole time, right?
Yeah, that was a real hard one, man, because people build on top of things, on top of things, on top of things, on top of things, on top of things. And so they just keep building on top of stuff, and everyone gets an order of magnitude, some order of magnitude less. So I do think it's time after 50 years of Unix that maybe we should have a reset to some other type of operating system that's based on some other ideas, like allowing for extensibility and like end users can extend these applications without destroying everything and somehow shipping that around as a sort of enhancement tool. I don't know. There's got to be ways of making this stuff easier to access and use.
The acronym SOLID should
more defined without having to go so low level. This stuff is still super low level from like the 90s.
Never be allowed to exist if it doesn't have like P solid, like performance, right? Like there should have been something about how do any of these things that you're doing affect the actual runtime of the program. So again,
for sure,
this is just my take on it.
I mean, he's a game developer, so he's more concentrated on that. But that's usually not the performance is not the problem. It's this other stuff. Building the thing, changing the thing, figuring out how the damn thing works, like going through the rummage pile of all of the dependencies, all that baloney, getting the whole system set up so you can even just debug it or run it. And how do you verify that things are actually working? If you make a change here, it doesn't destroy something over there. Like building a program that's not built that way? Come on.
A lot of these things are very difficult to prove or disprove because we don't have formalisms for them the way we do for things like algorithms. One of the reasons algorithms are probably better in terms of how far they've developed is because we can test them more concretely. We have a language to talk about them.
Yeah, they're a solved issue. That's why.
But I don't fundamentally think these problems of the code that's not the algorithm are as impenetrable as we're making them out to be. We just need to actually focus on something we can point to, something we can measure. Why does TensorFlow take 4 hours to build? Or whatever it takes nowadays. Why? That should not be happening. It does not do anything that complicated, right? So how did we get there? We can measure that. We know what's going on. And we know the kinds of things, the kinds of filter processes that we've been putting in people's heads result in code bases like that. We need to start like actually nailing those down and saying, no, don't teach people to do these things anymore.
Okay, so this is just a natural progression of things. As technologies are adopted and become standardized, they become lower down the stack, and there's just another projection. So this is the same thing that happened with the mainframe stuff right before Kenneth Thompson and Dennis Ritchie and what's his last name? Yeah, so Ken Thompson. So when he would develop Unix, he pared it all the way down. He started with, he called it a disk schedule. It was just the thing that actually went out and sought the sectors on the disk. That was his basic operating system. And if you think about it, that's all you need. You need something to get data, return data, and process data. And how you do that is what he talks about, the core of the thing. So he took all those massive, huge computer systems, all scruffy operating systems and batch things, and everything's built on top of stuff and all the old compilers and all, how it's all built. He pared it all the way down to the very core on a mini computer, which was actually out of date at that time, and that's where he spun it up, right? So there's always this gate comes where everything gets radically simplified. So KMP is one of those moments, which is why I'm a KMP developer. I'm really excited about the direction is because that's a platform that's like radically simplifying all this stuff that's sitting underneath it, like the iOS and the web and Android and the desktop and whatever else comes along. And then also the backend having one language, one IDE, one build system, one set of libraries. That's a combination for all that stuff. Makes debugging and makes communicating ideas a way. So it's radical simplification. So this happens every once in a while in the computer industry, and this is just one of those moments. And there will be another one, which will probably be the operating system. Someone will come out with some sort of operating system that's going to be based on something other than the Unix ideas, and we'll base that off something much more simple that allows us to like get into these applications, extend them, as opposed to they're just black boxes that we just have to use as is.
They're producing obviously bad results. That we can measure because it takes 4 hours to build, right? We can tell. So hopefully that gives a little bit of perspective on how I think about where bad code comes from.
Yeah.
I wish I had an answer that was more magical, but at the end of the day, I really think that bad code just comes from that one simple failure, and that is we have stopped measuring and talking about what we actually want, and we are almost exclusively talking about or measuring things that are largely fictional. They don't directly connect back. And once you make that jump, the next generation never knows about the earlier part, right? They only see solid. They don't know that there's all these other things they should actually have been thinking about. And solid was just someone's random idea about maybe some good rules of thumb.
Correct.
But you'd never teach that as your first thing, right? You'd always teach the evaluation of real metrics first.
Correct.
That was the end of the lecture. I hope.
So yeah, that's the end of the lecture. I'm going to post the rest of that stuff there, and I think that's a lot of my thoughts about it. So some of the stuff I agree with him on, and some of the stuff is like he's still gone in engineering mode because he's a game developer, and I get you from much closer to the metal. But as an application developer, which is like another type of not as intensely down into the metal. It's kind of up a layer up. It's more psychological and like who is our customer, like context, all that stuff. So I think having those kind of like this type of conversation around what's really what we're actually doing as software developers, I think it needs to happen more, and not so like you gotta do this acronym, and I use this acronym. Do you use this acronym? No, I use this. That stuff has to kind of stop.